Over the three classes of levers. There's a first class, second class, and third class. And as of now, you've been working with just a first class lever that we identify as a first class lever because the fulcrum is placed in the middle of the lever arm between the load and the effort, where your effort's applied. It is a first class lever set up in this arrangement. It would still be a first class lever if the fulcrum was offset. So I'll show you that as well. You can go ahead and measure the effort this direction. Remember, on a first class lever, fulcrum in the middle, effort on one side, load on the other, and we apply effort going down, or our force going down. It still would be a first class lever if we change that arrangement up, as long as that fulcrum is in the middle. So I can take it and offset it all the way to one end of my lever arm, because I know, just like you do, that when the fulcrum is close to the load, we get a better advantage. So I can offset it like this and put my effort way out far from the rest and get a better advantage. So this is still a first class lever because the fulcrum is centrally located here with the load on one side and the effort on the other. And then when I go ahead and use that, I can measure the effort needed to lift my load, again in newtons. So that would be a first class lever anytime that the fulcrum is centered. The second class lever has the load in the center. Typically when I think of a second class lever, the first thing that comes to my mind is a wheelbarrow. When you think about a wheelbarrow, the fulcrum is the wheel all the way out at the end. The load is somewhere kind of in the middle, even though it's more towards the fulcrum, right, because the wheelbarrow has a nice long handle. And then the effort is applied out farther. So this would be a second class lever where you have the fulcrum, then the load, and finally the effort. When we attach the effort in our class on a second class lever, we no longer are using the rubber band at the top, rather we're using the hook at the bottom. Don't forget to still zero your spring scale, but you hook it on at the bottom, and then we lift up this time, so we don't need to add those 5/10 of a Newton. We can just read the spring scale and find out how much effort it takes to lift a second class lever. Any second class lever could have the load in any variety of positions or the effort in any variety of positions. It just is a second class lever when the load is between the fulcrum and the effort. So that makes for a second class lever. The last class of levers that I want to talk about is the third class lever. You know it's a third class lever because the effort is what's going to be centrally located. Typically on these, they make a pendulum type motion. So when you think about a pendulum type motion, right, you're thinking about a back and forth kind of swinging or swaying motion. So any object that you can think of that's a real world object that you might use in kind of a pendulum motion, and again, it doesn't have to be back and forth, up and down, it could be side to side like this, would be a third class lever. So for example, a snow shovel would be a third class lever. The load is the snow that you're trying to shovel. The fulcrum is actually all the way at the end on a shovel. It's actually kind of an invisible fulcrum because it's not a specific point, it's actually at the very end of the shovel. And then if you think about where you apply your effort, you would apply your effort fairly close to the end, right? It's where you would hold your hands on the shovel arm. So this would be an example of a third class lever, right? Our load is all the way out to the very end, and our effort then gets attached somewhere in the middle. So you know it's a third class lever when the effort is in the middle, in between the load and the fulcrum. Again, in the middle does not mean centrally located on the lever arm. It just means that it's the item that you could identify in between the two. So that would be a third class lever. It seems that a lot of the objects we will experiment with and kind of use on a daily basis are often third class levers. So remember, third class lever, I'm going to show you a pendulum motion, kind of that back and forth pendulum motion. Could go this way, again could go this direction, and it's still a pendulum type motion. Often think of a grandfather clock. So the way that you can tell the difference between the classes of levers is that a first class lever has the fulcrum in between the effort and the load. The second class lever has the load in between the effort and the fulcrum. And a third class lever has the effort in between the fulcrum and the load. In addition, a third class lever makes a pendulum type motion in its regular use. When you guys come to class, you're going to be classifying real world objects as they are used in regular purposes in first, second, or third class.